Okay guys, this is your helpful hint video for FRQ 2015, 6A, B, and C. No calculator, signed this Friday, due next Monday. So this is kind of a cool situation because this is the first time I've been able to give to you an entire FRQ. This is actually one complete FRQ from the year 2015 AP test. So you guys actually have enough knowledge in your pockets to be able to do an entire FRQ now. That's pretty cool. Anyway, we'll go ahead and get started here. So consider the curve given by this function. Now notice that's an implicit function. And they were very kind and they told us the derivative already. That's pretty sweet. The first thing they want us to do on part A is they want us to write an equation for the tangent line to that curve at the point -1, 1. Well, I'm not going to do any helpful hints there. I feel like that's really straightforward. Just take a look at one of our example problems from the last part of our notes from today on Friday the 6th, and you'll see plenty of examples where we did that. So let's go ahead and jump down here to part B though. Part B is a little bit confusing. So I'll give you some helpful hints for that. Find the coordinates of all points on the curve at which the line tangent to the curve at that point is vertical. So we want to find all the points. A point is an x and y pair, so I'm looking for an x and a y pair on the curve, which is this thing here. This is my curve. Find all the points on this curve, all the xy pairs, at which the tangent line is vertical. Okay, so now that word vertical is very important. That's not something to ignore, obviously. So let's talk about that. Let me pause the video real quick. Okay, so I don't know what my curve looks like, but let's just say it looks like this for now. What would the tangent line look like at this point? It would look like this, and that's a vertical tangent line. Right? Now, when you have a tangent line, the tangent line tells you what the slope is at this point. So if you know what your derivative is, right, and you plug in your value for x and y, I don't know why I put 0 there, it's not 0, but you're plugging in your values for x and y, then that will tell you the slope of your tangent line, right? Once again, this is stuff from Friday. You take your derivative, you plug in the x and y values with the point that it's touching, and that tells you the slope of the tangent line, right? Well, this is a vertical tangent line though, right? Do you guys remember what the slope of a vertical line is? It's undefined. It has, technically speaking, no slope, right? In order for something to have a slope, it has to be decreasing to the right, and this function doesn't go to the right at all, or not function, but the line doesn't go to the right at all, it just goes straight down. So this slope is undefined, okay? Now, why is it undefined? Well, you guys know that slope, even though you can find the slope of your tangent line by doing a derivative and plugging in x and y, slope in layman's terms is rise over run, right? Well, let's take a look at this tangent line here. Say I go up this far here, we'll call it y. From here to here, I went up y. So I have a rise of y, whatever that may be, right? But what's my run? I don't have one. I didn't go to the right, I didn't go to the left, I just went straight up. So that means my run is 0. And when you have a 0 in the bottom of a fraction, that's sad. That's an undefined expression. So here's the deal. Here's what I want you guys to take away from with this particular slide. First of all, if it's a vertical tangent line, the slope is undefined. And if the slope is undefined, that means the denominator of your slope must be 0. And since slope is really just your derivative, that means the denominator of your derivative would be 0 if the tangent line had was a vertical line. So what that means is for this problem, if the tangent line is vertical at some given point x, y, that means that the slope, aka the derivative, would be undefined, which means that the denominator would equal 0 at that point. Oops, getting ahead of myself there a little bit. So 3y squared minus x would have to equal 0. Now that means if you add x on both sides, 3y squared is equal to x, right? So basically what this means then is that this slope or derivative will be 0 anytime, or not 0, undefined, anytime the 3y squared is equal to x. So what you're going to do is, where does that happen on this curve? Well, what you're going to do is you're going to do substitution. Replace x with 3y squared over here and solve for y. And don't forget to solve for x also. So that's a little bit of a weird question, but just remember, vertical tangent lines means undefined slope, means the denominator of your derivative equals 0. In which case we get this and we can do substitution to find the point where that occurs. So there's your map for how to do that problem, and I'll leave the rest up to you. Okay, let's go ahead and take a look at 6c now. Evaluate the second derivative at the point on the curve where x equals -1 and y equals 1. Well, once again, I don't think I need to give you guys any helpful hints there. We did second derivatives on Friday in class, and that's a very straightforward question. So we're just going to leave it at that. All right, so let's go ahead and move down to our next one, 2012 5b. All right, so there's a lot of blah blah in this problem, which really isn't necessary, but it's still good to read it and kind of do our best to understand what they're saying. Let's see what it says. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. Okay, fun fact. We're not going to use that. It's actually written right here, and I'll show you that just for fun here. The rate at which the bird's weight is changing with respect to time is proportional to, that means multiplication, right? The difference between the bird's adult weight and its current weight, which we're just going to say maybe that's the 100 there. But anyway, so basically they're saying this equation in sentence form. So we actually don't really need to care too much about that. I'm going to go ahead and get rid of it. All right, at time t equals 0, when the bird is first weighed, it was 20 grams. And that's what this means down here. B of 0 equals 20. At t equals 0, the weight is 20. So if B of t is the weight of the bird in grams at time t days after it's first weighed, then here's the derivative of B of t. So we have a function B of t, and then we have its derivative right here. Now we don't know what B of t is, but we do know what the derivative is. Okay. It says let y equals B of t be the solution to the differential equation. We haven't learned that vocabulary yet, but that's what this is. It's called the differential equation. Let y equals B of t be the solution to the differential equation above with initial condition, blah. All right, so there's a lot of stuff up there, and I would say you pretty much don't need any of it to do this particular part of the question that we're doing right now. All you need to know is that this is a derivative, and another thing you need to be aware of is that this b here, it's actually a function. So it might help you if you rewrite this first. look like this. Matter of fact, the first time I did this FRQ, since I didn't rewrite this as an actual function, I got the wrong answer. So it's kind of helpful to do that. You may not need to do it, but it helps in my opinion. Anyway, so there's that. They want us to find the second derivative. Well, we've already got the first derivative, so here's my question to you. How do you find the second derivative? Well, you just take the derivative of the derivative, right? All right, so here's my first helpful hint to you guys. Actually, before I get to the helpful hint, notice it says in terms of b, and what that means is they only want there to be a b in the equation, nothing else. And you'll see what I mean when we get there. It's possible to have something else in there, but they don't want that other stuff in there. All they want is a b. No other letters are allowed. All right, so here's my first hint to you. Hint number one, and I'm just going to kind of walk you through this problem. Hint one is this. So simplify this thing. It would be nice to just simplify this. Go ahead and try and simplify this expression first. Don't do any derivatives or anything fancy. Just simplify it. Pause the video and give it a try. All right, so the first thing you should have done is to simplify is just distribute. 1/5 of 100 is 20, and then we have 1/5 b of t, right? And that's our derivative of b with respect to t. Okay, now we want to find the second derivative. All right, so here's your helpful hint number two. Put this whole thing in brackets and find the derivative again with respect to t, so we end up with the second derivative. So go ahead and do that. There's a little trickster in here, so watch out for it. Pause the video and give it a try. All right, so first off, the derivative of 20 is 0, right? So that just goes away. Next, we have this, and this is where the tricky thing comes in. Does this variable match this variable? No. So guess what that is? That's an implicit function. That's a chain rule, right? So we take the derivative like normal. Negative 1/5 b would just be negative 1/5, right? But then we add a prime. And there's your second derivative, but we're still not done. You know why? The problem said find the second derivative, but in terms of b. They don't want us to have a b prime. They only want us to have a b. So I'm going to give you a hint here. Here's your helpful hint number 3. Helpful hint number 3 is there's another way to write b prime of t, right? It's this. So instead of b prime of t, I'm just going to put dv dt. We can replace that dv dt with something that has a b in it. See if you can find what that is. What can we replace dv dt with? Well, the answer is dv dt is that. So you're going to take this and you're going to put that in the place of the dv dt, and you've got an answer now. So you would end up with negative 1/5 parentheses 1/5 100 minus b equals the second derivative. And so there you guys have it. You could simplify it too if you wanted to, but this is good enough. And I put a note down here. This is only half of the question for 5B. They had another half to this question 5B that we're not going to do because we're not ready for it yet, but there you have it. All right, last helpful hint video for 2010 6A. Let's go ahead and read it. Solutions to the differential equation, blah, also satisfy blah. Okay, so basically they're giving us a derivative and a second derivative. Okay, that's all you need to know right now. this tells us y is a function of x, right? And this talk about particular solutions right now, we really don't care. F of 1 equals 2. Nice fact to know, but not for us. We don't need it. So right now, all you need to know is what's your derivative. This is a second derivative. Matter of fact, I don't think we're going to use this either, honestly. And this maybe. All right, so here we go. Actually, you know what? I just realized something. We do need this f of 1 equals 2. All right, so let's go ahead and read it. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Well, we need a slope, right? We need a point. And we need to write our equation out, right? We've done this many times now. Well, slope is right here, right? So you're going to take your derivative and plug in the x and y that they give you. Where's our x and y, though? It's right there. So now we can plug those in to get our slope, and we have our points, so then we're ready to write our equation, and we're good to go. Pretty chill. We didn't actually need the second derivative at all in this one. So that's the end of it.